Hello everyone, welcome back to my channel. So let's continue with our rest of the questions. That is, we are going to do question number 13 from exercise of chapter 1 from class 11. So this question states that pressure is determined by force per unit area of a surface. Okay, pressure have been given, that what is the pressure? So pressure is force upon area. The SI unit of pressure is Pascal, which is given below. 1 Pascal is equal to 1 Newton meter inverse square. Okay. Then if mass of air at sea level is 1034 gram per centimeter square, calculate the pressure in Pascal. So we have been given mass, which is 1034 gram centimeter inverse square, right? We also know that force is equal to mass into acceleration. Over here there is no acceleration, obviously gravity will come in contact, so acceleration due to gravity will be taken over here. Okay, and we know that acceleration due to gravity has a definite value, which is 9.8 meter second square inverse, right? But our mass is given in gram and centimeter. We have to convert it into SI units. Okay, so to convert it into SI units, first we have to convert gram into kilogram and centimeter into meter. We know that 1 kilogram is equal to 1000 grams. Okay, or we can also say that 1 gram is equal to 1 divided by 1000 kilograms. We can use this to convert gram into kilogram. And then we also know that 1 meter is equal to 100 centimeter, right? So we can use this formula to convert centimeter into meters. So let's do it. First we are going to convert gram into kilogram. So mass, which is 1034, okay, divided by 1000, okay, it will be converted into kilogram per centimeter square. So which comes out to be 1.034 kilogram centimeter square inverse, right? Now what's our work is? We have to convert centimeter into meters. This centimeter square inverse is actually, what is it? That is 1.034 kilogram. We can write it down, divided by centimeter square, right? Centimeter square is over here. So what we have to do? We have to convert this centimeter square into meter. What we are going to do? So we have to convert centimeter square into meter square. So 1 meter square, all right, is added, it's multiplied into the denominator, and because it is centimeter square, so obviously we have to square of 100 square centimeter square. Now what will happen? Centimeter square will cancel down and it will become 1.034 into 10 to the power 4 kilogram meter inverse square, right? So this is your mass. Now you can use this formula, which is pressure is equal to force upon area. Force is mass into acceleration due to gravity divided by area. Okay, let's put the values over here. That is 1.034 into 10 raised to power 4 kilogram meter inverse square multiplied by 9.8 meter second square inverse, and area is suppose 1. Okay, so when we are going to calculate it, when we multiply 1.034 with 9.8, it comes out to be 10.1332. okay, multiplied by 10 raised to power 4. okay, as you can see, meter and meter, 1 meter is cancelled down, and kilogram meter inverse per unit second square, right? So we can convert it into scientific value. 1.01332 into 10 raised to power 5 kilogram meter inverse second inverse square. Alright, now what we have to do, we have to convert it into, first we have to convert it into, there is question, let's go to question, into Newton meter inverse square, and then that Newton meter inverse square will be converted into Pascal. So we should know one thing, that 1 Newton is equal to 1 kilogram meter second square inverse. Okay, right? And 1 Pascal is equal to 1 Newton inverse meter, right? So if that is the case, then in kilogram meter second inverse, it becomes 1 kilogram meter inverse square second inverse square, right? So the Pascal becomes equal to 1 kilogram meter inverse second inverse square. So the pressure is, it was over here, that is 1.01332 into 10 raised to power 5 Pascal. Okay, so this is how you are going to calculate this kind of questions. Okay everyone, now our next question is, what is the SI unit of the mass and how it is defined, right? Though we know that SI unit of mass is kilogram. Okay, it is kilogram and it is represented by kg, right? So how is it defined? Its definition is given in NCERT in very well manner. So what is its definition? That 1 kilogram, okay, is defined as, it is actually, it is the mass that is equal to the mass of international prototypes of kilogram. Of kilogram. All right, so this is how you can define kilogram. There is another way to define kilogram. It is defined, what we have to do, we have to take the numerical value of Planck's constant. Okay, we know that what is Planck's constant, which is h. Okay, we will take its value. Okay, it is a fixed numerical value, we should remember, which is actually equal to 6.626, approximately that much, into 10 raised to power negative 34. Okay, we'll take this value, and when this value is expressed in joules a second, okay, so this when it is expressed in joule seconds का meaning है कि this is actually it's a unit, okay, and it will be equal to, okay, this particular value will be equal to, okay, we can say it will be equal to kilograms meter square second inverse. Okay, our next question is match the following prefixes with their multiples. What we have to do is we have to match their prefixes with multiples. So you have done it already, so we are just going to revise it. Okay, let's do it. First one is micro. Micro is actually 10 raised to power negative 6. Next one is deca. Deca means 10 directly, okay. Mega. Mega means 10 raised to power 6. Then is giga. Giga means 10 raised to power 9. And one is femto. Femto means 10 raised to power negative 15. So this is how you will match the prefixes. You have to learn these prefixes to solve different numericals. Okay. Next question is, what do you mean by significant figures? Okay. Significant figures are actually numbers or digits that are meaningful. Okay. They should be meaningful. What are they? They are digits. They are meaningful digits, right? Which are actually known with certainty. You should remember this. They are always known with certainty. Okay, we should know them that these are the actual numbers. Okay, plus 1 which is estimated or uncertain. Okay, means there is a number. Suppose there is a number 11.2. So this is a significant figure, right? Where 11 is certain and 2 is uncertain. Okay, and uncertainty can be, plus minus 1. This much value, not more than that. Alright, so this is what significant figure is. And this 1 is always added to the last digit, or it is deducted from the last digit. Alright, so this is certainty and this is uncertainty. Alright, so this is how you will know about the significant figures. Alright, today's last question will be 17th question. A sample of drinking water was found to be severely contaminated with chloroform. Okay, we know that what is the formula of chloroform? CaCl3. And it is supposed to be carcinogenic in nature. What is the meaning of carcinogenic? Means cancer causing. Okay, the level of contamination was 15 parts per million by mass. You should remember that it should be lesser than this, but way lesser than this, but it is having 15 parts per million by mass. We have to express this particular mass into percent by mass. Okay, convert ppm into percent by mass. And the other one is determine the molarity. Okay, not, you can say that molarity. Okay, this is molality of chloroform in water. Alright, what we have to do is, right, first we have to convert 15 parts per million to percentage by mass. So we should know that percentage by mass is equal to whatever number is in parts per million, which is 15 parts per means divided by million is 10 raised to power 6. Okay, and we have to convert it into percentage, means we have to multiply it with 100. So that comes out to be 15 into 10 raised to power negative 4. We can convert it into scientific notations, that is 1.5 into 10 raised to power negative 3%. So this was percentage. Okay, this is how you convert parts per million into percentage. Next is determine the molarity of the chloroform, right? For molarity, what we should know? We should know the number of moles of chloroform. And to know the number of moles of chloroform, we should know the molar mass of chloroform. So molar mass of chloroform is equal to carbon is 12 gram plus hydrogen is 1 gram plus there are 3 chlorine. 1 chlorine weighs 35.5 gram. Alright. So that comes out to be around 118.5 grams mole inverse. Okay. And according to the above equation which we have calculated, it means that 100 gram sample of water contains 1.5 into 10 raised to power negative 3 grams of chloroform. Okay, because this is mass percentage. Okay, so mass percentage means this much mass is present in 100 gram water sample, right? So if this much is present in 100 gram, then what is present in 1 gram? 1.5 into 10 raised to power negative 3, okay, divided by 100. All right. And in 1000 gram, or that is 1 kilogram, that is 1.5 multiplied by 10 raised to power negative 3 divided by 100 multiplied by 1000. So that comes out to be 1.5 into 10 raised to power negative 2. Okay. So can we convert it into number of moles? So we can convert it into number of moles. This is given mass. Okay, number of moles of chloroform will be, this is given mass, 1.5 into 10 raised to power negative 2 divided by, what was the molar mass? 118.5. Right? When we are going to calculate it, it comes out to be 1.266 into 10 raised to power negative 4 moles. Alright, and we can calculate the molality. Molality comes out to be, once again, number of moles of solute divided by volume of solvent. Over here, what is the solvent? In 1 kilogram, okay. What is the solvent? Solvent is water, and we have already converted into 1000 gram, right? So that is 1.266 into 10 raised to power negative 4 divided by 1. All right, that is 1.266 into 10 raised to power negative 4 mole kilogram inverse or we can write it down 1.266 into 10 raised to power negative 4 molal. So this is how we will convert parts per million into molality. I hope you have understood all the different type of questions which we have done today, and thank you so much. Have a nice day.